Hello, everybody. Welcome to week 2 of software development with Python. Week 1 was a very short week, so we basically were in preview mode all last week. Since there's some things that will show up on the Module 1 homework assignments that we haven't talked about in class yet, the date of that might get moved back. So instead of being due at midnight tonight, I'll probably push it back for like 3 days. And in general, if there's something that we haven't talked about the homework won't be due until after we've talked about it in class, and not like tonight where it's 3 hours after we talk about it in class, like 3 days after we talk about it in class. So I'll move the due date on that back to like Thursday. Let give everybody time to work on that. I see some head nods. If you haven't done it already, I know a bunch of people have already done it because it's just the basic Python syntax. Nothing too complicated there. A few things to go over this evening. One that probably should have looked at last week, Jupyter Notebooks. I wanted to wait this time until tonight because there's some people might have hit a slight error. Did anybody have trouble with like that pip, getting that to install software? If you're in pip, did your terminal say it didn't know what that is? Because we will be using that quite a bit, installing modules and stuff. And I wanted to wait until tonight to see who had hit that error, to just kind of show you what that was about. And then we'll install Jupyter Notebooks, which are an alternative to IDEs. So those of you that are actually in like a data analysis program, you'll probably use notebooks a little bit more often. So we'll talk about those. Yeah, then it looked like almost everybody filled out the introduction discussion board. I was going to wait a little bit longer, but it looked like that picture was okay, and I think everybody did fill it out. We'll quickly talk about that just in case somebody hasn't done that yet. Then some the basic syntax in Python, stuff that a lot of people have seen before. And I have a list of random odds and ends that aren't on the course objectives, or weren't built into that statewide course shell, or didn't make it into my customizations on the statewide course shell, that I'll just pull from every week. I looked at that list right before class and decided, maybe we'll look at a disassembler tonight, because it might be nice to see that at the beginning. And we'll talk about that when we get to it. First off, I want to address the issue that some people might have had as soon as she joins. As soon as Zoom lets her in the room, there it is. I believe she was one of the ones that added that. So an issue some people might have had is when you went and tried to install extra Python modules. Our example last week, the one from the useful odds and ends list last week, was the emoji library. I always like to start off with that in every one of just about every class, because emojis are part of our language. It's perfectly normal to get professional business emails all day long with emojis. And last spring, the SEC passed regulations that involved emojis, and certain emojis can be used as evidence in insider trading trials now. It doesn't get more official than that. So feel free to use them in your homework for your outputs. It doesn't have to just be text output. We can do better than that in 2024. We can do way better than just words on the page. I'm a big fan of that. Like when we have writing assignments and stuff, we can do way better than words on a page that look like they might have been done in 1920s with a typewriter. We can do a whole lot better than that these days. So alternative formats are often acceptable in my class, unless there's something in their instructions that specifically asks for text. Like when we get to the prompt engineering discussion board, obviously that is explicitly asking for text. But in general, I'm all about alternative formats and improvements and extra little things like that. More is always allowed. I can say it that way. Think of the instructions as the base level. It's not a perfect checkbox. If you want to do more and get practice and learn more, I will still give you feedback on doing extra. So I'm happy to do that if you want to go further than the class goes. So the instructions are like the minimum. Feel free to do more. But with those, when we're going to use a lot of things that didn't come with that default installation of Python. Oh, let me let him in the room. And I should add these names to the list so I don't forget about them. And then we'll do that. So Salamanca. So when we go to install extra modules, we were doing this a little bit last week. I'm using a quick shortcut. I'm on a Windows machine, so I'm going to hit Windows X. That gets all our terminal commands. Actually, I'm going to do a different shortcut. That's the one I use most often. Something that's very, very useful when we're working on projects is to go in through the File Explorer. So on Windows, push Windows E. That'll open File Explorer. For Mac users, you have to actually open Finder, or if you close everything else, you can open Finder. There's a shortcut for Finder, but I can never remember what it is. It's not a very, it doesn't strike me as very intuitive, but in Finder, we can navigate to where that is, where the files are. Mac users, you have to click through, but for Windows users, the address bar up there is actually a PowerShell input. Might want to, maybe you think better with the command prompt or use command prompt. You can think of it as a command prompt input, but if you weren't aware, command prompt doesn't do anything anymore. CMD in Windows, they removed it a few years ago and people freaked out because PowerShell is an updated version. Everything from command prompt worked in PowerShell, so they went ahead and removed command prompt, and people freaked out about change because people dislike change. So they put it back in, but nowadays all it does is forward commands to PowerShell in the background. So it doesn't actually, CMD doesn't actually do anything except forward commands to PowerShell, which all of the old commands still work in PowerShell anyway. But let's see, I'll go in my working directory. So maybe we're gonna work in a folder here. I guess I need to clone that one from last week. Right, we have the class repository, so that's probably where we want to work. So if you're on a Windows machine, you can do this. This Mac's a little bit different. The address bar, you can still do a bunch of stuff in the address bar, but if you're on a Mac, the best thing to do is down at the bottom of Finder, there's breadcrumbs. And if you right click or long click on one of those breadcrumbs, depending on if you have a 1-button or 2-button mouse, do the little context menu click on that, and then you have an option to open terminal in that folder. The Windows File Explorer, the address bar here is actually a terminal input. So if I wanted to like clone that repository, I can go to this folder and say git clone, and then I know the address of it, https:// If you haven't heard it before explicitly, since it will probably show up in this class, / is how we type protocol. That's basically across all our languages. That's the type protocol. You probably typed that a lot, but never heard that explicitly. So like when we're doing virtual servers, we'll do localhost protocol. When we look at MySQL stuff, we might use MySQL protocol, localhost :3306. Then / is telling the computer to use MySQL protocol to connect to things. So that is how we actually type protocol. It shows up in more than just web addresses. In this case, it is a web address. So github.com, then my account, Francis-Chris 5, and I believe it was SDEV 220-spring 2024. And then it has a .git extension, but Git is well known enough that it will know the extension if not. Pretty sure I typed that in, but that's what we typed in PowerShell last week to clone it. And on a Windows machine, you can type that right in the address bar. There's no, you can see the output. The output there was slow because I had to download however big it is, probably a few hundred kilobytes right now. But usually the output flashes by so quick we can't see the output whenever it does that way. But if you're doing something that doesn't need output, you can use that. or start PowerShell here. Well, actually, I'll go in this folder because here's where we're going to be working at tonight. If I want to start PowerShell here, you can just type it in there, or the old command prompt. I'm using the Alt-D shortcut. That Alt-D goes right there, or CMD, the old command prompt line. The one that's been around since the 90s, and they updated it, improved it. The new version accepted the old commands and the new commands, which is a modern syntax as opposed to the syntax written in the 1970s, which seems very out of place these days. And they got rid of it, but people don't like change. People freaked out, so they put a fake one back in there, and it made people stop freaking out. So I'm going to PowerShell, and when we install stuff, like we're going to use Jupyter Notebooks. So you might want to, we'll use the preferred installer package in this class. That's the one that came with the Python installation. It is not our only way, it is not our only Python installer, but that's the one we'll be looking at in this class. And if you want to try other ones, they're easy to find online. Anaconda is probably the second most popular after this, depending on what you're doing. The big thing with Anaconda is it comes with a GUI, so you can install packages by clicking with your mouse and seeing icons, which can oftentimes be a lot easier. But if your computer doesn't recognize pip, we need to make sure the computer knows about it. And this is something that actually applies to all of our programming languages. Whoops. Oh, that's why. I was trying to type clear and my finger was in the wrong spot. In order to make a computer, tell a computer about our programming language or anything we want the computer to know about, we have to edit the system environment variables. So on a Windows machine, go to edit system environment variables. I'm going to include the one for what to do for Mac and Linux as well here in just a moment, because it's a similar name variable. It's just that on Windows, we have a GUI to get to it. On Mac and Linux, we have to do it from the terminal, but it's just concatenating another address onto a variable that's already built into the system. So search for environment variables, or it's under system properties, the advanced tab. I find it quickest just to search for it, and edit environment variables is button down here at the bottom. So these are basically all of the things that our operating system knows about. And a very, very important one if you're heading in software development is this variable called path. And it is called path on all of our operating systems. On Windows, Linux, Mac, Chromebook is a Linux as well. So it is always called path. And this is basically the programming languages and the software that your computer knows about. So here on the GUI, notice there's one in system variables and one in the user, and it will look in that order. So, or look in the order going down. So first thing the operating system is going to do if you ask it to run something is it's going to look at the current user path variable, and if it can't find it, then it'll look at the all users version of the variable. So I'm going to go ahead and put that in my local user account. If I come up here, notice it's just a list, an array or a list. We'll talk about those very soon. Hopefully everybody's seen arrays and lists by this point, because we're going to talk about more advanced data structures in this class. But on all of them, it's just a list of, notice it's just some addresses. And in particular, this first one, that's where Python's installed. Actually, that first one is where pip is installed. Second one is where the Python interpreter is installed. And then right next to it is a folder called scripts, and pip is inside of that folder. So we just have to tell it where pip is at. So you might have to, what's a good way to look at this? One of the easiest ways to find it is if you go in your Python interpreter, because you will have this, even if it doesn't work, even if Python's not working in PowerShell right now, you can open idle and you should see that prompt with three angle brackets. That's the prompt coming from the Python interpreter, not the operating system itself. If we import SYS, which stands for system, we import that module. One of the things on there, we can print the system module .path. This is where Python looks for the modules. Before long, we will add stuff to it, but you'll see it is just a big list stored in Python in a script called SYS, sys.py. So it imports that. There's a named list called this, and this will show where Python is installed. So probably don't want the zip folder at the end, but if you back off one, then that should be the folder where Python is installed on your machine. Before long, we'll be making projects and we might need to point at things, right? If it's in the same folder, that's easy to import because Python's going to look in the same folder first. That's actually what this one is. Don't add anything on the path. Just that means look in the current folder. But what if we're more organized than that? And in order to get to the module that we wrote in the same project, we have to go up a level to the parent folder and then down into another folder. We might want to add that to the path. So we can just do sys.append. We'll see list soon. If you haven't seen list, we can just append the other address on to the end. Or what I like to do is, since I know it needs to be looked at, instead of append, I'll use insert and go ahead and put it at the beginning. Put it at the beginning of the list because it's like, I know I wrote some modules that are going to be looked for every time. So I want to add them to the system path, but only on this project. We'll see that soon. So right now, kind of preview mode, and that's a nice, quick way to find where Python's installed. And if your terminal's not recognizing Python at this point, you can do that from idle, which would have installed, which comes with every installation of Python. I'm going to go back over to PowerShell. So we'll run the exit method in Python. So exit with parentheses, actually the exit method to get back out to the PowerShell prompt. My computer knows about Python, but if yours doesn't, you just take one of that address, make sure you're looking at the one that has the Python interpreter in it, and paste that into your system variables. So for example, I use the Sublime text editor. So maybe like here in this thing, it's like, okay, I want to use this text editor, which right before class, I actually took it out. So I know this is fixing to crash. It's one thing I do like to show error messages. We will see error messages a lot, is when you have textbooks and nice polished tutorials, you only see the finished product, not how they got to that. And since we have we don't have a lot of time, but we have a little bit of time, I like to look at the error messages and make sense of those and understand how to fix them, instead of just seeing that finished polished version in the textbook. And I think by this point in your software development pathway, everybody knows that's not how writing code goes, right? We usually end up with lots and lots of error messages, which, speaking of that, I do practice the examples beforehand to avoid just wasting time from all those little typos and things like that. You all know how that goes when we write code. Even after decades, that still happens constantly, those little issues. I don't want to waste a bunch of time in class for that, but I do like to see error messages. And at least once every class, we will do an unprepared example so that y'all can see that when I don't practice the example ahead of time, it is still full of those little errors like you're probably used to when you write code. Okay, so maybe I want to open the text editor I like. So I use the Sublime text editor. A really nice thing about that is it will use the GPU for text editor purposes. So if we're trying to take telemetry on our software, right, we're developing a piece of software and we want to know how much of the processor and RAM it's using, the Sublime text editor will use your GPU. So then when it runs, you see what the software is actually doing on the CPU and RAM and the registers, and you don't have extra stuff from the text editor IDE you're using. That's why I like that text editor. But any of them work. It looked like a lot of people chose VS Code. That's a popular one. It's actually an open source project. Microsoft just downloaded the open source files and put their name on it, which is technically legal. And then the promotion of it's the big one. When it was originally created, the nice thing about the Electron framework was that it was a really good IDE online. there's a web application online, and they make it look like a desktop app, which we will see how to do at the end of the semester, because for our final projects, we will also be making a web application. If we want a desktop app, we just make that web application look like a desktop app. If we want a phone app, we just make that web application look like a phone app. Just kind of put it on a different screen. So basically, VS Code is a web application running in a browser with the address bar removed, so you can't go to any other pages. Very, very simple concept. We'll see it soon. A lot of people using that. The one really good thing that you all have probably seen before, if you're using that, may have been picked up on, people that work at Microsoft, whenever they have downtime, they have a requirement that if they have downtime, they are supposed to make YouTube tutorials and talk about how great VS Code is for doing that particular thing. There's nothing VS Code does that we can't do in any other text editor or IDE. Or I often refer to IDEs as text editors. But there's not, when it was created, the only thing special about it was a really nice online. Usually the online ones are kind of sketchy. But it was a really nice online one. So there's nothing VS Code does that we can't do in any IDE. But those tutorials are super nice because that's some of the best computer people in the world making tons and tons of tutorials, because we don't show commercials for text editors, right? They had to promote it somehow, and that's what they came up with. And we end up with thousands and thousands of tutorials from some of the best computer people in the world. And yeah, they just, if you're watching a tutorial and they start talking about how great VS Code is for that, that's somebody that works at Microsoft. It's a requirement for them it's something they have to do for their job. I use the Sublime text editor because, like I said, it does the text editor processing in the GPU, or on my cheap laptop here, the integrated GPU. So then when we run our software, we can see just the software on the resources, like the CPU, and get better telemetry. And the text editor doesn't clash with the processor, where our processor's running. If I tried to open that here, so Sublime, and then the dot, and try to open it, I should get an error message. Or, yeah, it'll search for it. Wants to know if I want to download it. So my computer doesn't know about Sublime Text Editor right now. So I need to add that to the environment variables. Let's see, I'll close this. And to do that, we just have to tell the computer where to look for that. I happen to know, so I'm going to come over here to program files. So you can do this if it doesn't know about the some software you want to use. Like I'll be using Spider in class. If it doesn't know about code already, your machine should know about code. That usually automatically adds to that. I use Sublime Text, which is in this folder. So right over here is that executable that I actually want to run, SUBL. So I just need to grab this address right here, copy that, and paste it onto this list. There's a new button there, but you can just also double click in the thing. Okay, there. I'm gonna do one more while I'm here, because I erased them both right before class. Sublime Merge, that's from the same company as the Sublime Text Editor, but this is the Git desktop client that I like. It's my favorite one that can be used for free for more than 30 days. There's Git Kraken is by far the best, but it is you only get a 30-day trial on that. It's not cheap, but remember, when you're out there making really good software development money, not cheap software is rough as a student, but when you're out there making lots of money as a software developer, the IRS is going to want a really, really big chunk of it. And or if your home country is another country, the tax department in your home country will also want a really big chunk of that. Most countries in the world do have that tiered thing, so the percentage of taxes you pay goes up as you make more money. But things like the software that you use for developing as a software developer is an itemized deduction. So at least an itemized deduction. Sometimes they could be straight write-offs. it is definitely a business expense. So when you're out there making good money, paying for the good software is definitely worth it. But again, this is one I like, so I'll copy that address and just add it to the path variable. Hit OK to apply all those. And now I'll go back in Windows Explorer. I just hit Windows E to get to that. I'll click, that way y'all can see what I'm doing. Go back in here. Now, if I wanted to do that, I could do Sublime and then hit dot. And now it knows about Sublime and has all this stuff. So I can get right to the Git integration and stuff from there. Yeah, all of that, all of those things. So that's how you tell the computer about the software we want to use. Do I have any? I might have to use Git Bash. Git Bash for Linux or Mac users. In your terminal, you can just do echo $path in all uppercase letters. There's all the software that we know about. So just concatenate something onto that list. So we'd say link path without $, is reassign path colon and then another address. So well, an example for Linux or users, you probably use your root directory, and then maybe it's in Etsy. That's where you install code in Etsy on a Linux machine, something like that. Hopefully that looks familiar to the users. That obviously that's going to throw an error if I do that here, but that's how you add more environment variables. And that's definitely a necessity for software developers because that's how we tell the computer about the programming languages it knows about. And it does require a restart. So if I try to run the Sublime thing here, it doesn't know what that is. But if I close out of PowerShell and restart it, which I'll do Windows X, terminal from here.
So we do that to environment variables.
Mm-hmm. Yeah. So the path variable it's just the path variable directly.
What was it? Path dash
path. $path is the name of the variable. So do you have terminal open right now? So if you just type echo $path in all uppercase letters.
How do you add them?
Oh, you were just writing it right next to it. Let me do that again. So git bash. So you use the variable, so path equals for assignment, and then $path is how we retrieve it. Then a colon, and then whatever the variable is. You're on a Mac, so users/application, and just type it right like that. Or it is in your bash RC file. So if you just open a file, there's a file called bash RC. If you just open that up, you can just type it in directly in the text file. A couple ways to do it. I guess the key thing, the note to search later, since you're probably not going to remember every word I say, right? The note to remember is how to concatenate to the path variable on a Mac. And Google will bring up those examples, but we do have that in every operating system. And as software developers, we need to add to that because, well, the software we're developing will depend on those things. So kind of like how Sublime wasn't on there. And you do have to restart your terminal. It only checks the environment variables when it first starts. So if you make a change to them, you have to restart the whatever terminal you're using to apply those changes. So you'll do that to get pip installed. And I guess the next thing, you should probably look at notebooks. So I'm gonna do pip install. If you have pip, it'll be this line right here. Pip install notebook. This will be definitely necessary for our class. with some subtle changes. It's already satisfied on mine, but you'll see the little download meters. Oh, TQDM. We didn't look at TQDM last week. TQDM. That's the little meters, so we probably want to see how to make the little meters. We'll do that here in a second. So it's already installed on mine, and notebooks are a little bit different than our Python scripts. So once it's installed, to run it, we type Jupyter space notebook. It should automatically add it to the path and everything. It's part of Python, so as your operating system is looking through all the things it knows about, it will notice there's something called Jupyter in the Python files. When we do this, it runs in a browser. A few advantages. The big thing is instead of one large file, we have lots of little cells. That's how we put things together. So I'm going to navigate over to that local version of the GitHub repository we're using for this class. We're going to see that in a few places, but again, anything we do in this class, the upload button should work fine. And I got to get Zoom thumbnails out of my way. I should probably do that on the TV here in the class too, because you don't necessarily need to be looking at those right now. Need to look at Jupyter. So you go to where it's looking at, and obviously hit the new button to create a new one and create a new notebook. Some of your assignments are it'll explicitly say create this in a notebook or create this in a IDE. Most of them you can do either one will be fine. The one that absolutely will not work, we'll see why here in a moment, is when we get to automated testing. We can't do automated Python testing in a notebook. We'll see why in a few minutes once we have something here that is saved. So I'm going to go ahead and select the Python interpreter. Oh, we can have multiple Python environments. So mine showed the latest version. So I'm on a brand new computer. I only have one version of Python installed. But we have these little cells. Seem like organization things. That's the first thing people think of. One way you can think of it is as we write a cell. So I'll do a print hello world. Nothing too fancy there. And up here in the run button, we can run that selected cell. Notice how it ran that and created a new cell. So they're independent. So we can run just little sections at a time, but they also know about the previous ones. So if I was to like say import sys here, and instead of hitting enter, I'm going to push alt enter. Alt enter runs that cell and then creates a new one. And then do that same thing we saw earlier, print sys.path. See where Python's looking at it. But this time, instead of alt enter, I'm going to push control enter. The always change for a Mac. So command enter on a Mac. And notice how it ran that cell, but it didn't create a new one. So the important thing there is notice that we imported sys and this cell, the second cell, and then we used it in the third cell. So each one of the cells, you can think of that as like an independent Python script that imports the stuff from the previous script. So kind of like implied here, right at the top, there's a import second cell from above, right? It's implied that we're importing the cells from above, and then we can go back and run other things. So like maybe instead of importing sys, like, oh, I meant to import operating system, not Python system. So we go back and import that. I'll hit control enter and notice that those numbers there, it's not just 1, 2, 3 going down. It shows the order we ran them in. So if you go back and make a change up here, you might need to rerun the stuff down below too. So there's a little bit of jumping back and forth. This is definitely the preferred way to do data analysis with Python is using cells because they're very organized. When we have plots and things like that, they'll show up on there. A little plus sign to create a new cell, as we were in for, so we put that here. Or you come down to this one and do plus afterwards. I tend to pretty much always use the Alt-Enter, Option-Enter on a Mac. The obvious changes if you're on a Mac. Option-Enter will run it and create another cell, and Control-Enter or Command-Enter will run that cell without creating a new one. And I pretty much always do it that way. And we have cells to run code in, but we can also do what's called markup cells. So see this little drop down up at the top, right under the main menu with, I guess that's the tool ribbon. So the drop down says code, but we can also do markdown stuff. And here, actually it takes markdown and markup languages. Here we can just put text. This is a markdown cell. Alt-Enter. And notice how here, there's nothing to run, it's just text. So instead of comments, so really don't need comments in there, you can use markdown cells. If you know markdown language, that's fine. GitHub uses markdown language. Let me do that here. I'll do another one, switch this to a markdown cell and do a dash markdown, underlines. So notice they made it big and bold, but we're in a browser, right? A browser knows HTML, so we can also use markup languages. Markup uses tags, you're all probably seen that. Markup uses extra symbols, it adds to it to specify what it is, and Markdown uses abbreviations. So if I come in here, notice that to make that a level 1 header, just do a dash. To do a horizontal line, it's just 3 underscores. 3 dashes also does a different person. So a markdown, it replaces formatting with special characters, and a markup uses tags. If people have seen HTML, has everybody seen HTML? Because we will use that. That's how we're going to make our GUIs. We're going to use HTML forms, and we'll just process them with Python. So we're doing some full stack stuff, but your final project will need that. If you have not had an HTML class, please let me know, and I'll get together a review for you. You're not really going to be graded on the HTML part unless it just doesn't function at all. It will still need to function, but that's how we're going to use markup languages to a web app showing on a website to do our final projects with Python code. We will see that very, very soon with the Django framework. And then it's not really part of this, but remember that thing I said about VS Code, how we take a web application and just make it look like a desktop application? In the final project submission, I did put together a video walking through the steps for that. Yeah, really, we don't need that part until your final project's finished, but I did go ahead and make a video for you to walk through that, how to do that next step, because that's what should be covered in the SDEV 257 class. But for some reason, SDEV 257 hasn't ran yet, even though it's been on the books for like 5 years, and it's on the list of elective choices for y'all, at least. A couple people, it's on the required list, and it hasn't ran, even though it's been on the books for 5 years. But in assignments, the final project submission, I did make a video showing how to launch a Django web application in a manner that looks like a desktop application. That's how they're mostly made these days. But we don't really need that part till the end, and it does require 5 programming languages. It's not a lot, but we just have to jump between JS Node, 2 different things in JavaScript. Obviously, Python, the one ours is written in Python, HTML, and JSON. Oh, 6. 6 bare minimum in order to get that up, to make that happen. And this is a Python specific course, so it's kind of hard to justify covering 6 different languages, especially since it's boilerplate code. like if you follow along that video, you can copy and paste that forever. And there's like 3 or 4 words that will need change for every project you ever do. And it will be obvious when you see it. I think I even pointed out in the video. So it's boilerplate code, but yeah, we don't need that part to later. But we will be using markup languages, and since browser's running a thing, I can make, like, say, a level 2 header that says markdown, closing tag, and then maybe a paragraph. This is a markdown cell formatted with a markup language. Oh, whoops. Notice how it's changing colors? So apparently I left it as a code cell. I need to switch that to a markdown cell. There we go. Now it changes colors different and just changes colors for the tag very subtly, if you can see that on there. In that paragraph, I don't know, maybe throw a small one in here. Random words. Just have a couple lines, and when we hit Alt Enter to run that cell, notice we get that. We can back up and edit this one. So the nice thing is we can do all of that stuff. This is formatted with markdown syntax. So markdown, we use a smaller number of special characters, hence down, smaller number. And mark up, we use a bunch of extra Unicode characters to add into tags. Markdown syntax, GitHub also accepts markdown syntax for readmes and wikis and fact pages. I don't think we'll get to wikis and fact pages on GitHub this fast, but they exist and they take markdown. So you see, we can make things look a whole lot better than what a comment would be. So instead, that's why data analysis really like to go with notebooks, because then instead of just adding some comments about stuff, or when there's a write-up on the analysis, right, finish your analyses and do a write-up, and then it's like a report, you can do it in markdown or markup language syntax and make it look really, really nice right next to the code that where it runs. We'll be using those a lot. Our emojis worked, right? We did that a lot, library last week. Import emoji, print emoji dot emojize, and here's another random example. Color. I need to show you how to add color to that output too, right? Right now, everything, whenever you do print in Python, it prints black and white except for the emoji library song. We can do color. If you're a Linux user, you probably know it. It takes those same color codes, the Unix color codes, square bracket, 33M, all of that stuff. If you're a Linux user. Otherwise, we will see that soon. I just added it to the list, trying to remember. And then some sort of emoji here. Here's another example, colon. And again, remember, we have a short list. We don't have the full list, because unlike all of Unicode, we don't have thousands of graphic designers making emojis. There's 2 guys in Mexico City desperately trying to keep up with those thousands of designers. So we come over to the Python site and scroll down this one, or just bookmark this. Carpe Diem 20.github.io is the list of ones they've made. So maybe first place medal, colon, first place middle, colon, in the string. Do the other one, run that, and you can see it shows our emojis and stuff fine. Basically just another place to write code. Organize, makes it nice and organized. and go back and forth, run bits and pieces. Anytime you submit your homework as a notebook, though, what I'm going to do first thing I'm going to do is come up here and run all cells. Run all cells, and if they're and look for crashes. If it crashes, there's a 10% deduction, and then I start digging through looking for problems. I think I mentioned before the late penalty is 3% per day, but it stops at 50%. If I'm grading, I stop at 50% as well. But until we run out of time at the end, I'm more worried about correct than quick. So right, A or B is probably okay. But if I start to see a lot of mistakes, you're much more likely to get an email from me with a list of things to fix, asking for a resubmission than a bad grade on something. So that's the first thing I do is hit run all cells. When I do those, use markdown cells instead of comments. That's really, really useful. Have some basic types. That's what one of our assignments is this week. So has everybody seen a little bit of Python before? It's a dynamically typed language. That means we don't have to say what type it is. There's three categories of languages. Strictly typed is like C family. Like if we want to store an integer, we have to say, okay, we're setting up a spot in RAM for an integer. We're going to refer to it by this name. That's all a variable is. It's a named location in memory. I'll take this example to draw a little chart that I'll be using quite a bit this semester. Make sure everybody knows how to do this. So, diagram that we'll be using quite a bit this semester is what's called a stack heap diagram. These are data structures, more refined data structures than like a list or an array. A stack is a last in, first out sort of data structure. You think of it like a stack of plates. Use that word, right? When we go eat dinner, we finish eating dinner, go wash dishes. The last plate that we put up in the cabinet is probably the first one we grab at the next meal. We grab off the top of the stack. So we stack up our instructions, and then the computer pops them off. That's the most natural way for a computer to run. So when we write stuff in a text file, a computer reads those instructions in backwards and creates a stack. So the last line in our file is the first one the computer reads, and it creates a stack, and then it pops those off the stack as it runs. We'll be making a stack for a while. Heap is a dynamic data structure. We'll talk about what it is when we get to data structures, but we won't make a heap. I'm going to point you towards an example that has the code written out so you can see what it is, but it's a very specifically organized type of self-balancing binary search tree. But it is the fastest way the CPU can do things. The fastest way a CPU can get through RAM is what that is. So that's what our operating system usually deals with RAM. Basically, when I do these diagrams, this side over here is our code, and this side over here is going to refer to RAM. And later this semester, we will talk about what heaps and stacks are. We will definitely make a stack. We'll make a stack and see how we do those. That's the one that's kind of most natural for a computer to do. But if we want to store something, we say, tell the computer, okay, we want to store the number 3. It's going to come over, choose a spot in memory, throw in the bits, all the ones and zeros to represent the 3. I'll just draw a 3 inside the box for our diagram purposes. And the computer is going to remember that because it's going to know it as starts at bit, I'm just going to make one up, 27,458 is, we're in Python, so 32 bits long. Right. This is where the indexing start at 0 comes from, because we ask for the beginning and count from the end. We ask before we get to even the first bit, so it's spot 0, but we don't count until we get past the last bit. There's that little discrepancy y'all may have noticed. We'll see that a few times. But that's how the computer starts stuff. But we're never going to remember that, right? I just made that number up and I already forgot what it is. 27,000 something. There's no way to remember that. So we need a better way to do that. That's how the computer remembers it. It's like your neighborhood, right? When you're talking to your neighbors, you can say things like the Joneses' house or that place that used to have green shutters. But if somebody's driving through your neighborhood looking for something and they stop and ask you for directions, it's not going to mean anything if you tell them the Joneses' house. Or if you tell them the place that used to have green shutters is completely useless because they can't see what color it used to be painted. So we need a way for outsiders to tell what it is. So like the street address, that's what a variable is. On the board, it's harder to write things, so I'm just going to write X. So I'm going to say, call that X. And then we'll refer to that as X over in our code, but the computer remembers it this way. Kind of what's going on in there and just sort of introducing these pictures. Does that diagram make sense? This is a standard diagram for discussing what's happening in the CPU and the RAM and the registers and all of that and what's actually happening in the code, which we will see quite a bit of that later. So we'll be using a lot of these diagrams. Make sure that makes sense. Our code gets processed as a stack and RAM is almost always a heap. We can do other things in RAM, but don't really use any languages anymore in the modern world. Modern world doesn't use any programming languages that do anything other than a heap. And we will also make a stack and a heap ourselves. So just make sure that diagram makes sense. We will see that a few times, one of many, when we talk about what's happening internal to the machine. So with that stuff, there's three ways we can tell the computer to store something in RAM. Strictly typed, like the C family, where we say, okay, we have an integer. The computer sets up enough space for an integer, and that's all we can ever store there. We can't, it gives us that much space. We're not allowed to put a string into that spot. We can't change it at all. It's very strict what it is. So strictly typed. Then Python is dynamically typed, where we don't have to say what type it is. We say, okay, we want to create a variable, put a 3 in there. The Python interpreter is going to take a little bit longer than that strictly typed language did and figure out that that is an integer. So once we put a 3 in there, we have to continue using it's an integer. We can't use that as a string. Everybody's seen the casting issues with Python before. Cannot concatenate string and int. That error message is very common. I'll do an example here. And then the other type is loosely typed languages, where basically we treat all data types as equal. There's quite a few of them out there. We don't need to dig into that right now, but instead of like dynamically typed figures out what type it is at runtime, and loosely typed languages, it figures out what type of data it is at processing time when we actually go to try to get an output from it, as opposed to store time whenever it's stored in RAM, like Python does. So with loosely typed, we never have to worry about what type it is. I'll just do that example I put on that stack heap diagram on the board. So we want to store a variable. We want to store the number 3 to use later in our code. So I'll just say there's a variable called X, going to be assigned number 3. I think most people are familiar with this. Part of stretching this out at the beginning, if y'all haven't noticed yet, I'm easily distracted. So I like to go kind of slow so they'll be used to how I give lectures before we get into the really deep stuff. And they will get quicker each time. I guess for now, I'll just print that out. So print that variable was a plus the number 3, or plus whatever's stored in X. I know it's a number 3, but this is that error message I was talking about. So I try to run that. Everybody's seen this error message before. Can only concatenate strings, not a string and an integer. There's a couple ways to deal with that. One of the most straightforward one, we can directly cast it into an int. Casting. Casting means we're going to explicitly change the type, and I'm sorry, we're not going to cast that into an int. We're going to cast that into a string. It was an int, and we need it to be a string. So we can run that code now, and we get that printed out. We can also print formatted. So if we put an F right before our string, that variable was a, and then we have a couple of options. We could just leave a little space here, put that in the string, and then a comma, and then we make an array of the variables we want to put in. What I like to do is in those, put some curly braces there, and then put X right in those curly braces. Formatting style number 1, I'll put it that way. Run that code. I really like this one. It automatically does the casting. There are lots and lots of different ways that we can print formatted strings. W3 Schools has a side of it. Print format string Python, something like that. Oh yeah. A little note I like to make: always look at official documentation first. This is the user manual. Use the tutorials to learn to read the user manual. Tutorials have an upper limit. Tutorials only introduce stuff. The user manual has everything about it. See a bunch of different options. Like they did it this way. And then some numbers or representation of whatever's in that data type. Lots and lots of different things here. Oh, this looks like the one I just used. Similar to it. But then there's other ones. And we see where we have lists, and we can refer to indexes and keys, or sometimes we have empty ones, and then afterwards we put a list of things afterwards. A bunch of different options, so you can choose the one you want. Obviously, like always, the documentation is kind of confusing. It's like, okay, this stuff's confusing. Let me find something easier to look at. Geeks for Geeks has good stuff. I was looking for W3 Schools. There we go. W3 Schools almost always has great introductions. So here they're showing how to do the print formatted stuff. String.format is one option, or use the placeholders. You can put dot format afterwards, or like I saw, like I just did, we put an F out front, and that is the same as putting dot format afterwards. Multiple ways to do things. So even when we cover things in class like this, you'll want to make sure and look at different alternative syntaxes, because maybe you'll like one of the other syntaxes better. It just makes more sense in your mind. Look for the one that makes the most sense. But see, when we look at the official documentation, same thing for Geeks. If we go to Geeks for Geeks, they've got a nice simplified version, 0, 1, and 2, and then afterwards we do dot format and make a list of the variables we want to put in there. 0, 1, and then 1 shows up twice. So that's really useful if we're going to use one of those variables more than once in the output. Other things, but make sure you look at those extensions and alternative syntax and things, because the reason there's lots of ways to do that is because we all think a little bit different. So one of those formatting rules is going to make more sense in your mind than the others. And that's the one you're probably going to want to use the most often, because that's going to come out easiest in your code. So pretty much all of Python's like that. We're not going to dive into it again, but just be aware of that when we cover stuff, that you might want to check the docs and see about alternate syntax and stuff for it. And maybe there's another syntax that will make more sense to your mind. And if it makes more sense the way your mind processes stuff, obviously it's going to make your code a lot easier to write. And then after looking at the tutorial, come back over here and be like, oh, that's what they're saying here. Now I can make sense of whatever this mess is, like much more complicated ones. it can get very detailed. But that's like some of the like reading assignments and stuff, right? Random practice on your own later. For our purposes now, be aware that there are multiple syntaxes for almost everything built into Python. So you know, especially if you find something confusing, like that's really hard to remember. I have to look up the example every single time. Check for alternate syntax. There might be some. We have our types. Another very useful one is we can check if isn't check the type. So there's a method built in is instance. I'm gonna look it up. Do the documentation again. Check type in Python. It's is instance. We'll look at there's all that is instance tutorials. I don't see the docs. Python docs. There it is. Typing. Oh, this doesn't have what I was looking for. Go back and Stack Overflow probably has it. Is instance, yeah. Then two things, they don't really show what they are. So if is instance, we're going to check if X is an instance of a string, right? Is that variable X a string? And if it is, then we can print, well, then we could just concatenate without the casting. But if it's not, we need to do something else, right? Print, it's a string. We run that code. Notice nothing printed because it's not string type. Quickly review on these. In most of our languages, we have else if. The general description of Python is it's a dynamically typed object-oriented language with significant white space. So in most of our languages, we have else if and spell out what we want it to be, but Python has significant white space, so we can't have a two-part keyword. I think everybody probably knows that abbreviation, right? So we abbreviate that into elif, short for else if. Is instance X a bool? Print it's a boolean. And we could go through and check all our types. I'm just going to jump right to the end and review the syntax for an if-else structure. Everybody's seen those before. If, elif, else, and you have lots and lots of elifs, which is the abbreviation for else if, because white space matters in Python. Else, it's probably a number. I get zoom buttons out of the way. Our quote marks are interchangeable. I guess I can do that. It might be a number then. The one thing is we can't, well, it's highlighted in red here. We can't open with a single quote mark and close with a double quote mark or vice versa, which does give us one layer deep of things. Over the years, if we actually wanted to include that, I have found it's better just to do an escape sequence. Always do an escape sequence because we can only go one layer deep, and everybody's seen escape sequences before. Quotation marks mean something to our code, but in this case, we want that to be part of our output. So any symbols that the Python interpreter knows, if we want them as part of our output, we need to escape out of Python coding and use that. Like a tab, that's really important, right? We have all these tabs here. We can use tabs or spaces. We have to use the same number of spaces or the same number of tabs every time. It doesn't matter as long as we use the same number every time, and we can't switch between them. That's one thing if you're switching between different IDEs and trying it. Maybe your first IDE used tabs and your second one used 4 spaces. And when you open the file in a different IDE, it's going to and type some more, those won't align anymore. Cause indentation errors. We'll deal with those when we see them. But tabs are very important. As long as you're consistent, tabs or spaces, the recommendation from the people who wrote their Python language is 4 spaces. So most of your IDEs will be set up to put 4 spaces whenever you push the tab key, which if yours is not, you can just go in and reassign what the tab key types. Instead of a horizontal tab, just type 4 spaces with it. Usually an easy thing. \T for a tab, \S, so that's escape out of Python coding and put a space, tabs and spaces, and a new line. That way there's something after it. /n's the one we're probably going to use most often. Or maybe carriage return new line. These are all from preferable. It doesn't always happen. So carriage return refers to a typewriter. A new line is just when we would spin the little wheel and roll to the next line. But if all we do is spin the wheel, then we're still typing way over across the page. The carriage, that's the thing that holds all the pieces, all the paper to a typewriter. We want to usually, if we want to go to the next line, we want to spin to the next line and return to the beginning of the page. Most cases in computer output, there is nothing on the next line. So if we go to a new line, it can only go to the beginning. But that's not always the case. Microsoft OneNote is a good example of that. If all you do is a line feed, you're still going to be way over at the left or the right-hand side on the next line because it's not an empty line on the next one. There's already some reserved stuff. So we might want to do a carriage return line feed. In the output. But that's when the escape sequence is. It ties into regular expressions. We'll see regular expressions soon. Run that code. Wait, why didn't it? Oh, it doesn't know where this is. It didn't like the space. There we go. Notice we worked in the quote mark, the tab. It might be a number then, tab, new line, maybe a character return. But it gives us a way to check the type with the number. And that's an important thing to do for error handling without actually getting into try catch blocks. We'll talk about those soon. The standard example of try except is the syntax in Python. Try of catching errors. The standard example in textbooks and tutorials, because they're pressed for time, is just to print out a string. But we just saw a minute ago, right? If I had that \S, what happens if there's an error? What happens if we don't catch the error? It stops the run and prints out an error message. So when we get to those sections in textbooks, our textbook is no exception from others because it's restricted for space. Tutorials are restricted for time. So there are examples of handling exceptions is to stop the program running and print out a message. But that's what happens if we don't handle the exception. So that's not exception handling. It is not uncommon for your exception, the handling part, to be 3 or 4 times longer than the actual program part. And hopefully that code never runs, because the goal is to not stop the program running. It's to fix the problem. But we'll see a small example of it in class because it is very, very time consuming to get into that. Then loops, and then we'll take a break. Everybody seen loops before? We have 2 in Python. So a while loop will run while our condition is true. Let's make it a duplicate of x. X is going to be as count is. I'll just walk up. Count starts at 0, while count is less than, say, x, whatever x is. And I'm going to take a moment to point at this syntax. There's alternate syntax, and there's something here that this is what I think of as general Python syntax. We have keyword, something unique to our situation, a colon, and then we indent the stuff that goes with it. Same thing up here on the if else. Keyword, something unique to our situation, a colon, and then we ended it. That's what I often think of as Python syntax. So whenever we're with those alternate syntax things, that's what I'll often lean towards. The file handling I will do is let me add another cell. Add another cell with open file.txt for reading is read file print read file dot decline, something like that. I'll use this syntax instead of what you probably saw in the SDEV 140 class. SDEV 140 class I know does something different. But I feel like this one is more Python syntax. Keyword, something unique to our situation, a colon, and then we end it. So we'll see more of that as we go along, but I just wanted to point at that basic syntax, make sure everybody's familiar with it. And I guess that's also a good example. I'm easily distracted. That's why I start off so slow with lectures going so slow, so y'all can get used to me before we get into the really interesting stuff and go quicker. And I'm bouncing all over the place. I'm easily distracted, so feel free to interrupt me at any point and ask questions if you're interested about stuff, and we'll go down some rabbit holes. We don't have a ton of time, but we do have time to go a little ways down rabbit holes further than our course plans put together before the semester started included. There are some pretty deep rabbit holes we can get to in Python. What do we want to do? I'll just print something out. Print count. That'll work. Run that code. And we got to an infinite loop. Gonna be a problem, right? Eventually it'll crash. Notice how it did stop on its own. So what I want to do is make sure, here's our stop button. It got stuck, so maybe hit refresh or stop. We can come back in here and start editing again. Oh, it's not working. Yes, there it goes. Count. Well, another option. Notice how it's a little bit difficult to get it to work. Will Control C work? Everybody's seen infinite loops before, right? The thing to watch out for. And just like always, it's kind of stuck. So I'm just going to crash the program. There's a stop button here, but as you can see, I'm spamming that stop button like crazy and it's not doing anything. So I'm just going to close this, crash the whole program, go back out of here. It noticed it's crashed, tried to close the socket, but it's kind of stuck doing stuff. Anytime you're in a terminal, it works on all of them. Control C is your cancel command. So that's your keyboard override for anything your terminal does. Anytime a piece of software gets stuck, that is the ultimate way. Go to the terminal it's running in and hit Control C on every operating system. That's cancel. I think it actually might be Control C. So it's one of the ones that does it, that is still Control. You can give it a try. If you hit Control C, does it say keyboard interrupt? Yeah. Okay, yeah, that's cancel. Every once in a while, there's something that's still the control key on a Mac. I will try to specify when it's the command key. Oh, I'm going to start that again. Jupyter Notebook. Oh, that took 2 minutes longer than I was planning. Before I start that again, let me point at one thing and we'll take a. So notice how it's still doing stuff. We have the checkpoints. The last one was 7:12, so it hasn't been that long since the last autosave. So it's still working. I do want to point out one thing real quick here before we run it and fix that while loop. Actually, I'll do this. Notice that if I open that in a text editor, anybody recognize that syntax? It's definitely not Python syntax, right? So notebooks are a JSON file. So when we get to automated testing, unit test in Python, yeah. So down here, our Python code is just a string in this JSON file. So the notebook is notebook's a JSON file, which means automated Python test will not work on JSON. So when we get to unit test, that has to be done in a regular IDE or text editor, whatever your preference is. Or maybe a couple different ones, because usually at this level, I like to recommend to people try different IDEs, see what you like, what you don't like. Check the blogs for like the 12 best, 10 best sort of things. See what you should be looking for in a text editor or IDE. And really choose one, because at this point in this class, you're probably either heading towards a software development career or a data analysis career. I guess a couple other people might be doing something, but you'll be writing a lot of code either way. If you're in this class, you're going to be writing a lot of code. So make sure you have one you like, and we'll talk about other things, ergonomics and keyboards and stuff. Let's finish that loop example real quick, because I think everybody's seen loops, and then we'll take a break. Sorry, I meant to take a break 2 minutes ago. Over the years of teaching, I've gotten better anticipating how much time I'm going to waste going through things. Documents, delete folder, into our thing, and I'm going to open that untitled notebook here. Notice the file extension is IPYNB. So the IPython, because again we have the square bracket instead of the triangle brackets, so it's IPy. It's built out of the IPython console, and then NB for notebook. Print count, and then we'll do count plus plus. So we didn't lose much at all when we just crashed it. It's constantly saving in the background. That's another really nice thing about notebooks and why data analysts like it, because it's pretty common that data analysts will give the Python code something way bigger than a computer can handle in our modern world, and it crashes, and then they'll have to come back and start breaking it down into pieces, and they'll do that several times to figure out how much they need to break it down. And the autosave in notebook really helps there, because then they don't lose much. Especially if you like pause for a minute or so, like I just did here before running it. Oh, whoops. We don't have plus plus count plus equals one. We do have the reassignment operators. I call them reassignment operators. We can change the value of count, but we can't do an initial one here. And we have that for all of our operations: times, add, subtract, multiply, divide, modulus, all our basic operations. Has everybody seen those before? There's a couple prerequisites. So what do we have? Count is less than X. I'm in Python, so I should probably not be using C syntax. I put some space here.
Undeclared X.
Undeclared X, and we ran that last time, but we haven't run that this time yet. So I'm come up here and do run all cells, and it's going to start here at the top and work its way down. It should, until it hits something. Okay, so we need to import sys. We change that, run all cells, work its way down, and eventually get down here. There's our count one. For I'll do C in range of 3 to get kind of the same thing for loop. Everybody's seen for loops and while loops before. Our general rule of thumb is if we know how many times it's going to happen, which maybe not as the programmer, but when it starts running, the computer will know how many times it's going to happen. The length of a list or something, we don't know how long that list is, but it will know. If we know how many times, it's a for loop. If we don't know how many times, or if it may never run at all, then a while loop. So like temperature, right, for your thermostat. While temperature is less than 70, turn on the heater. But if the temperature is 75 all day long, that's never going to run. Or like last weekend, that's probably never going to shut off. It's probably never going to reach 70. So we don't know how many times that while loop would happen. That's when we use a while if we don't know. And a for loop is for when we do know. Print C, we'll talk about those in more detail later. We're already past time for a break. All right, I'm going to take a break 5 minutes ago. Quick coverage of syntax and all of that. We can give this a name, file, save notebook as, and instead of whatever's on here, I'll save it in the same place. But instead of in untitled, I'm going to call it example 1 notebook. It opens up, and again, we have that thing where it hasn't ran. But we're 5 minutes past break time. We'll load that up on GitHub in a minute and see that it runs on GitHub. Close that. Save changes to untitled, discard untitled. We don't need that one because we saved it with a different name. Close that, and then again, Control C is the cancel command in your terminal on all terminals and all operating systems. Whether you're on PowerShell, which runs on every system, PowerShell is cross-platform. Mac and Linux were working on a modern version of the terminal, and when Microsoft finished theirs, both of them were just like, okay, they did so good, we're just going to do compatible with PowerShell. There's no way our version is going to pass PowerShell, so they just did with compatibility. So PowerShell does work on every system. Just Google how to install PowerShell on Mac, how to install PowerShell on that thing. I think there are some advantages, but whether it's PowerShell, Bash, C, Man, Prompt, Fish, whatever terminal you're using, Control C is always your cancel command. That will be important when we start doing virtual server stuff in our frameworks here in a couple weeks. Be very, very important when we're on virtual servers. Break. We probably should. I'm gonna take a break about 5 minutes ago. 10 minutes sound good to everybody? I know I'm getting really thirsty, and I've got some good coffee. I made some good coffee right before break, right before class started. So my laptop says 7:22. We'll get back to it at 7:32. See y'all in just a moment.